Have you ever looked at the world and just thought, it's all so random? Well, what if I told you that's not the whole story? Turns out there are these amazing mathematical blueprints that help us see the patterns hiding in plain sight. Today, we're going to decode some of the most powerful tools in all of statistics. So let's jump right in.
And that's really the big question, right? How do we find any kind of order in all this chaos? I mean, think about it. From a simple coin flip to something more complex like how many people walk into a coffee shop, our world is just swimming in uncertainty. But here's the cool part. Chaos isn't the same as being totally unknowable. Statistics is like this special lens that lets us find the rhythm, the structure, the order hiding underneath what looks like just pure chance.
Okay, so here's the game plan. First, we'll talk about what these blueprints of randomness actually are. Then, we'll dive into three of the heavy hitters, the binomial, the Poisson, and the famous normal distribution. And stick around, because at the end, we'll do a super quick glossary to make sure all the key ideas really stick.
All right, let's get into it. The blueprints of randomness. I keep using that term, mathematical blueprints. So what exactly are they? Let's nail down the one core idea that everything else today is built on.
So the official name for this is a probability distribution. And you know what? The best way to think about it is like a weather forecast, but for chance itself. A forecast can't say with 100% certainty that it will rain, but it can tell you there's, say, a 70% chance of rain, and maybe only a 5% chance of snow. That's exactly what a probability distribution does. It takes all the possible things that could happen, and it assigns a likelihood to each one. It's how we turn that big, messy chaos into something we can actually get a handle on.
And yeah, whoa, as you can see here, statisticians have been busy. They've come up with a ton of these blueprints. Every single one of these formulas is like a specialized tool in a toolbox, designed for a very specific kind of random situation. But don't let this overwhelm you. Seriously, you don't need to know all of them. We're just going to focus on three of the absolute most important and common ones.
Okay, let's kick things off with a real classic, the binomial distribution. This is your go-to, your number one tool whenever you're dealing with a situation that can only have two outcomes. Think about it, success or failure, heads or tails, win or lose, yes or no. If it's one or the other, you're probably in binomial territory.
And here's the formula. Yeah, I know. At first glance, it looks a little intimidating, right? All those letters and symbols, but I promise you, the idea behind it is super simple. It really just boils down to three key ingredients. Let's break them down.
Okay, so everything hinges on understanding these three little pieces. First up, you've got n. That's just the number of trials, how many times you're going to do the thing, like flipping a coin 10 times. Simple. Next is p. That's the probability of success on any one of those tries. So for a fair coin, p is 0.5. Easy enough. And finally, x. That's the number of successes you actually care about. That's it. See, it's really that straightforward.
So, let's put it into practice. Say you want to know the odds of getting exactly 7 heads if you flip a coin 10 times. Well, this is a perfect job for the binomial distribution. Your n is 10 because you're doing 10 flips. Your p is 0.5, the chance of getting a head on any single flip. And your x is 7 because that's the outcome you're interested in. You just plug those three numbers into the formula and bam, it spits out the exact probability.
All right, ready for our next blueprint? Let's build on what we just learned and talk about the Poisson distribution. Now this one's a little different. It's not about a set number of trials like flipping a coin 10 times. Instead, Poisson is all about counting how many times something happens over a specific interval, like a period of time or even an area of space.
And you guessed it, here's the formula for Poisson. But again, don't get hung up on the symbols. Just focus on what it does. Its entire purpose in life is to help us predict the chances of a certain number of things happening in the future based on how often they've happened in the past.
Now, what's really cool about Poisson is how beautifully simple it is. It basically comes down to just one key piece of information. Lambda, which is represented by that Greek letter lambda. And all lambda is the average rate, the historical average. It's just the number of times an event usually happens in that time period you're looking at.
Let's go back to that coffee shop example. Imagine you know that on average, 5 customers walk through the door every hour. Well, that 5 is your lambda. Now, with the Poisson distribution, you can figure out the probability that in the very next hour, you'll get exactly 8 customers. Or what about only 2 customers, or even 0? You can see how this would be incredibly useful for things like staffing and inventory, right?
Okay, so let's make sure the difference between these two is crystal clear.
Binomial is for a fixed, countable number of tries, like 10 coin flips. You know it's going to be 10, no more, no less. Poisson, on the other hand, is for a continuous interval, like an hour. You don't know how many events or trials might happen in that hour. It could be 0, it could be 20. So a good way to remember it is binomial is for counting trials and Poisson is for counting events over time.
And that brings us to our final distribution for today. And honestly, it's the superstar of statistics, the normal distribution. You'll often hear it called nature's favorite, and for very good reason. This pattern shows up everywhere in the real world, absolutely everywhere. So, here's the math behind it one last time. But honestly, with the normal distribution, the formula is less important than its iconic shape. And I bet you've seen this one before. It's the famous bell curve. You know the one, that perfect, symmetrical hill right in the middle that smoothly tapers off on both sides.
The entire shape of any bell curve is determined by just two parameters. That's it. First, you have mu, which is just the fancy symbol for the mean or the average. That tells you where the center of the bell is, the very peak of the hill. And second, you have sigma squared, which we call the variance. All that tells you is how spread out everything is. Is it a tall, skinny bell curve, or is it a short, wide one?
And this is why we call it nature's favorite. It describes an incredible number of things you see every day. The heights of people in a population, blood pressure readings, even errors in measurement. They all tend to follow this curve. And there's a deep mathematical reason for it, called the central limit theorem. It basically says that when you have a whole bunch of different random things all adding up together, the final result almost always ends up looking like this beautiful, predictable bell curve. It's like a fundamental law of randomness.
Whew. Okay, that was a lot, I know. We've covered some major ground. So before we finish up, let's do a super quick recap with a little glossary to lock in all the key terms we talked about today.
And here they are, all lined up. You've got binomial. That's for counting successes in a set number of trials. Then Poisson, for counting events happening over a period of time. And normal, that's our classic bell curve that we see all over in nature. And the two parameters that shape it? Mean tells you the center, the average, and variance tells you how spread out the data is. Honestly, if you can walk away remembering these 5 ideas, you've totally nailed the core of this whole topic. So, I want to leave you with this one final thought. These things we talked about, these distributions, they aren't just a bunch of abstract formulas in a textbook. They're like a new set of glasses for looking at the world. So now that you know the blueprints, now that you know what to look for, what patterns are you going to start seeing out there?
أهلا بيكم. النهاردة هنشوف مع بعض إزاي علم الإحصاء بيساعدنا نجاوب على أسئلة ممكن تكون تبان مستحيلة. هنتكلم عن الأفكار الأساسية في الفصل السادس من كتاب مقدمة في الإحصاء الرياضي.
خلينا نبتدي بسؤال يبان صعب قوي. إزاي نقدر نعرف حاجة عن مجموعة كبيرة جدا من غير ما نكلم كل فرد فيها؟
يعني تخيلوا كده لو عايزين نعرف متوسط الوقت اللي ملايين الطلبة في الجامعات بيقضوها على الشاشات. هل منطقي إننا نروح نسأل كل واحد فيهم؟ لا طبعاً. ده مستحيل عملياً.
في الإحصاء المجموعة الكاملة اللي احنا مهتمين بيها دي سواء كانت ناس، منتجات أو أي بيانات بنسميها البوبيوليشن أو المجتمع الإحصائي.
والحل الذكي للمشكلة دي هو إننا بدل ما ندرس المجتمع كله بناخد مجموعة أصغر منه نقدر نتعامل معاها. المجموعة الصغيرة دي هي اللي بنسميها السامبل أو العينة.
وده بالظبط هو جوهر اللي بنسميه الاستدلال الإحصائي، العملية اللي بنستخدم فيها بيانات من العينة الصغيرة دي عشان نطلع باستنتاجات عن المجتمع الكبير كله.
تمام؟ فهمنا فكرة العينة والمجتمع. طيب إزاي بقى بنستخدم العينة دي عشان نخمن المعلومات اللي عايزينها؟ خلونا نشوف أول أداة معانا.
أبسط طريقة هي إننا نحسب الرقم اللي عايزينه من العينة بتاعتنا، والرقم الواحد ده هو اللي بنسميه التقدير النقطي أو البوينت استيميت. ده بيكون زي ما بنقول كده أفضل تخمين واحد نقدر نقدمه.
اللي يهمنا هنا نفهمه هو إن متوسط العينة اللي بنرمز له بإكس بار بيكون هو التقدير النقطي بتاعنا للمتوسط الحقيقي للمجتمع كله اللي رمزه ميو أو ميو. يعني ببساطة شديدة بنستخدم متوسط المجموعة الصغيرة عشان نخمن متوسط المجموعة الكبيرة.
بس هنا بيظهر سؤال مهم جدا. يا ترى إيه فرصة إن التخمين الواحد بتاعنا ده يطلع صح بالملي؟ يعني يطلع هو بالظبط الرقم الحقيقي للمجتمع كله.
بما إن تخميننا كنقطة واحدة غالباً مش هيكون دقيق بنسبة 100%، فإحنا محتاجين طريقة أذكى، طريقة تاخد في حسابها نسبة عدم اليقين دي.
وهنا يجي دور فترة الثقة أو الكونفيدنس انترفال. دي بقى مش بتدينا رقم واحد، لا دي بتدينا نطاق كامل من الأرقام اللي غالباً الرقم الحقيقي موجود جواه.
عشان نفهمها أكتر، الموضوع عامل زي ما تكون بتستنى قطر. التقدير النقطي كأنك بتقول القطر هيوصل الساعة 3:15 بالظبط، دي مخاطرة. إنما فترة الثقة كأنك بتقول القطر هيوصل في أي وقت بين 3:10 و3:15. طبعا الطريقة التانية دي أفيد بكتير وفرصة إنها تكون صح أكتر.
طيب احنا دلوقتي اتكلمنا عن كذا مصطلح مهم. تعالوا بقى نلخص اللغة دي كلها ونحط كل حاجة في مكانها عشان الصورة تبقى واضحة تماما.
الجدول ده بيلخص لنا كل الكلام اللي قلنا، هنلاقي فيه كل مصطلح بالإنجليزي والعربي والرمز بتاعه وشرح بسيط ومباشر بيقول لنا ده عبارة عن إيه، ملخص ممتاز لكل المفاهيم الأساسية.
ودلوقتي بعد ما الأدوات دي بقت واضحة، الفكرة الأهم هي إننا نقدر نستخدمها عشان نجاوب على أي سؤال تقريباً، ونكتشف حقائق ومعلومات عن العالم حوالينا كانت ممكن تفضل مخفية. إحنا كده بنحول مجرد بيانات خام لمعرفة حقيقية.